Okay, so let us take up this question. So suppose there is a plane mirror like this. Plane mirror is inclined like this at an angle of theta. The plane mirror is inclined at an angle of theta. And a ray of light is coming like this. This ray is parallel to the base. Okay, this ray is parallel to the base, and you can consider that um, ray means you can take object. Okay, object is coming, not just a ray. Sorry, we're taking object. So there is an object which is moving in this direction. With this direction, velocity is parallel to the base. Okay, and it has some speed. Let us take its speed is 2 meters per second. Okay, that's the one. Now the question is find the, and you can take this direction as x-axis and take this take as y-axis, right? X and y-axis coordinate system you take. So velocity is along x-axis. Okay, object velocity. The question is find the velocity of image vector. Try to calculate. Can you calculate this? Yeah, mirror is not moving here. Mirror is at rest. It's inclined plane. Okay, it's rest. If you can solve this question, that means you have understood it. This angle value also take. Angle value is 60 degree. This angle value is 60 degree. Okay. Nishant, you also try. Both of you try this question. How do you solve it? Anyone? Answer. Suppose this question comes in your NEET or in JEE main, how will you solve it? No? Your answer is root 3 I cap plus j cap, right? Nishant, any answer you got? Your answer is minus I cap plus root 3 j cap. Okay, let us take that. So, how to approach this question? Uh, you can resolve the velocities along the which direction? Along the uh, parallel direction and perpendicular direction, right? That's what we need to do. And the parallel component is not going to change. Perpendicular, you have to reverse it. That's all you have to do, right? But the thing is that when you do the reverse of this, this is neither x-axis nor y-axis, right? X-axis, y-axis is like this way, that way. So definitely you have to think. If you reverse it, you have to write them as vectors. If you can write them as vector, you can definitely reverse it. Okay. So let us write them and this as vector. So you know this angle is theta. This is also theta. That means what? So this is parallel to this, right? So this is also going to be theta. Theta is 60 degree, we know that. So let us resolve this 2. So this 2 cos 60 degree will become 1 and 2 sin 60 degree will become root 3. So root 3 component is perpendicular to that and 1 is parallel along that. So if you take about image, if you talk about the image will be definitely inside this. That image will have this 1 in this direction, right? 1 meter per second will be, and this root 3 must be reversed, so this will be root 3 in this way, which is perpendicular to this. So this will be the image velocities, but we want to now resolve it along x and y. That's what we want to do, right? Because they are neither along x nor along. We want to resolve along horizontal and vertical. Then only we can say anything about I cap j cap. Okay. So think about it. So this one, which is parallel, right? Theta, theta. So this is parallel to this plane, right? This is making theta with what? Horizontal only. So this is making same angle theta here, 60 degree. So one we need to resolve, right? Another is root 3. Root 3 which is perpendicular. How much this will be making angle with the horizontal? Think about this. This how much angle it is making? This angle, because this is 90 degree, correct? Now this is 90, so this will be 90 minus theta. 90 minus theta. So this is making 90 minus theta with the horizontal. 90 minus theta. Now you resolve it. So this one, which is this theta, means this is 60 degree. So resolve this. So 1 cos 60, 1 by 2, and this will be 1 sin 60, 1 by root 3. Okay, and this one, which is this root 3 is making 90 minus theta, and this will become theta, right? 90 minus theta means this is 30 degree then. Now resolve this root 3 into this direction, two direction. So root 3 cos means root 3 by 2. So root 3 into root 3 by 2, that will become 3 by 2. And here root 3 sine means half. So this side will become root 3 by 2. Now you take total you find out along x-axis. So along x-axis, when you try to find out how much it will come, I think here I am mistake. Root 3, 1 cos, 1 sine. 1 sine means 1 by root 3 by 2, right? Sine 60 degrees, root 3 by 2. This is root 3 by 2. This is 1. Okay, now tell me how much along x-axis. So along x-axis resultant 3 by 2 minus half. 3 by 2 minus half means 1 it will come, right? 3 minus 1, 2 by 2, 1. And this is going along this direction. So how much? Root 3 by 2 plus root 3 by 2. So 2 times root 3 by 2. So that will become root 3. Okay, done. So along x-axis it is minus 1. You can see that this is the image velocity. So velocity of image along x-axis minus 1 I cap, and this is plus root 3 j cap. That's the correct answer. Clear, Sam? Nishant, correct answer. Yes, got this. Hmm. That is what you have to learn how to solve problem. Hmm? So, what mistake did you do that you figure out? Okay, what mistake? Is there any other shortcut way of solving? I want to solve within a minute. How can I solve it within a minute? That is, there is also another approach to think about it. Suppose if this is the mirror, right? This is the mirror. Directly we'll think about it. If this is the mirror and if this object is moving like this way, object is moving like this way, which is making same angle theta. So image must also move in the same manner so that it will also make angle same angle theta. Remember, image and object move symmetrically, right? Image and object move symmetrically. Okay. So now think about it. Think speed of course will be same. So if it is moving with 2 meter per second, it will also move with 2 meter per second. So if I can directly calculate this angle with the x-axis, then game will be over. And really game is getting over because this theta, theta, 2 theta. So this angle is going to be 2 theta. 2 theta means 120 degree. So directly we can resolve this to 2 cos 2 theta. That means 120 degree I cap plus 2 sine 2 theta. That means 120 degree j cap. Over, this is the velocity of image. One step it is over. Cos 120 degrees minus half. So if you substitute 2 into minus half I cap plus 2 sine is root 3 by 2 j cap. So you got the answer in one step, right? You can see that it is coming. This is what is shortcut. Okay, shortcut means it will give you within one step, one or two steps. Will save time. Are you understanding this? Hmm. But minus sign, I think you have taken 60-degree angle, but this is 120-degree will come, right? Did you see where is the mistake you have made? Nishant, you also did by the same approach? Ah, that's right. Okay, done. So now you can solve questions like that. Let us move next. Now we are going into spherical mirrors. Spherical mirrors. Spherical mirrors. Okay, so spherical mirrors, if you take it is a part of a sphere. Suppose if I draw a sphere of radius, center is C, radius is R. Okay, so a part of this sphere, let's consider a part of this part. Okay, and this side is painted. So inner surface is reflecting surface. Inner surface is reflecting surface. So this type of surface where the outer surface is painted, this is called painted. Okay, silver painted. Silver painted. Outside is silver painted, inside is reflecting. Reflecting means it is polished. Okay, reflecting surface means it is a polished surface. Polished surface. Okay, so this type of mirror is called concave. Concave mirror. Convex mirror means we can do it like this. Is same diagram I will show it. Okay, same diagram I will show it. Suppose this surface, if I paint inside, then outside surface will become reflecting. Outside surface will become reflecting. Inside surface has become silver painted. This has become silver painted. So this is what we call at this is called convex. Convex. Okay. So convex mirror means the outer surface is reflecting and concave means the inner surface is reflecting. But don't think that inner outer confusion should happen. You can sometime take this like this way also. I can keep it like this way also. Then it doesn't mean that inner is reflecting. Outer is only reflecting, right? Outer means outside. So this is still convex only. Convex only. Okay. So we need to think about like how are we considering the surface. If suppose if I show like this, and if I show this as painted, then this is still concave only. Concave. Okay. So concave convex. What is concave convex? It is a part of a sphere. The entire sphere may be bigger sphere, very big sphere it may be, but this part that you are cutting out from that sphere is a very very small segment. So this length or this portion, very very small portion it is of that sphere. Okay. So this is a very small portion and this is called also aperture. Aperture means what? I will explain that aperture. Suppose this is a full sphere and let us say I cut this much portion of this sphere. This much portion of the sphere I cut it. Now if I consider from the center if I consider, I'd make a circle here and like this I'll drop a perpendicular. Let us say this is x and this is the radius of this sphere. Okay, this angle will be theta, let us say. Okay, and there is a radius of, because this is going to become like a disk here, this is going to become like a small disk, circular disk. Okay. So the radius of this circular disk is, let us say, r, small r. That is small r. Okay, that is called the radius of this aperture, or if you take diameter of the aperture will be 2r. So r, small r is radius of aperture, radius of aperture, or you can say it is the aperture radius of aperture, or sometime you can say the size of aperture. Okay, diameter, aperture diameter means 2r it will become. So you know when we talk about the spherical mirrors, we keep very very small size, very very small aperture. So this angle theta is also very very small, very small. Okay, so we keep a very very, so this segment is very very small segment. Now when segment of the mirror is very small, the rays which are falling on that has to be considered paraxial. So that is what we are going to take. We are going to take paraxial rays, paraxial rays only. All the rays which will be used in the ray diagram, they are paraxial rays. Okay, paraxial rays makes very very small angle of incidence, very very small angle of reflection. All those angles are very very small. Okay, they are paraxial rays. Fine. So then let us go further in detail into this spherical mirrors. Um, what are the important details? If you see, last time I have already given for marginal rays the formula for this focal length is not equal to r by 2, if you remember that. Okay. R1 minus 1 by 2 cos theta. Right. Yeah, that's what it is. Okay, so for spherical mirrors, what are we going to study? First of all, the spherical mirrors, there are some important terms that we can note it here in this diagram itself. Spherical mirrors, either this way, or let me draw another fresh diagram. Spherical mirrors. So let us consider that this is a concave, and let us take that this is convex, concave, convex. So the midpoint of this, the midpoint is called pole. Midpoint is pole. P is the midpoint. P is called pole, and pole is nothing but midpoint of mirror. Midpoint of mirror. That is called pole. Here also midpoint. And a line which is going cutting this mirror in this equal half, right? This line is called principal axis. Principal axis. Principal axis is what? It is a normal line. It is not that just it is cutting. Principal axis is cutting the mirror, but it is normal. Normal means what? Normal means it is making 90-degree with the mirror. Okay, either this side or that side. So principal axis is a line which is cutting the mirror into equal half. That means it is passing through the principal. It is passing through the pole, and it is perpendicular. That means it is a normal line. Normal line means what? It will pass through the center. It will pass through the center of the circle. So this center C is called center of curvature. Center of curvature. Okay, and this distance between this and this, that is called radius. Radius of curvature R. So R is called radius of curvature. Radius of curvature. Today our task is to wind up this mirror topic. So that next class we start with diffraction. Okay, so now we are considering only paraxial rays. So focal point F is called the focus. Focus. This side, and here also this side F. This is focal length. F is the focal length. F is focal length. And focal length is going to be equal to R by 2, half of radius of curvature, because it is paraxial rays. Because it is paraxial rays. All the rays we are going to take paraxial rays. That is why we are taking like this. Okay. Now object can be anywhere in front of this. Object can be anywhere in front of this. Okay. Anywhere. Here, anywhere. Okay. Of course, when you want to make the image, you have to keep object in front of that. And this pole is considered as the coordinate of this. So pole is the origin of coordinate system. Origin of coordinate system. So using this origin, now let us try to do calculations. So first calculation is what is the mirror formula and magnification formula. Very important thing, that we'll try to do that. Okay. So suppose if this is a, start with a concave mirror. Suppose this is a concave mirror. Sign convention. Sign convention is standard sign convention. We need to note. This is the pole. So this direction is plus x-axis, and this direction is minus x-axis. Above is plus y-axis, plus y. Below is minus y-axis. So pole is 0, 0. Of course, in real life, if you consider, because it's a part of a sphere, it is going to be 3 dimensions. So 0, 0, 0 you can give. There can be z-axis also coming out, but generally z-axis calculation is never done. Right? But in reality, all the x, y, z is there. It's a 3-dimensional thing, not a. The sphere is a 3-dimensional figure, right? It's not a 2-dimensional figure. But for our simplicity, we make it like a two. It looks like a circle, but it is not a circle. It's a 3-dimensional figure, right? Okay. So now we want to find out. Suppose that there is a point here. This point is representing an object. Its distance from here is x. Okay, and its distance from here is y. Remember, x, y is distance I am taken. I have not put any convention right now. X and y is just the distance. Okay, x and y distance. Otherwise, I can write this as minus x plus y. I can write, if I have to put convention, note that if I have to put convention, I can write this point as minus x comma y. But right now x and y represent the distances, plus minus that we can decide afterwards. Okay, right. So what is this? This is a point. Okay, this is a point, and these are the distances of this. I want to find out. I want to find out where the image forms. So also we should note that the rules for drawing the ray diagram, rules are very clear. What are the rules? Suppose if you take a concave mirror, okay, concave mirror you take, and suppose this is the principal axis, right, and this is the pole. So there are three rules are there for making ray diagram. So if a ray is passing parallel to principal axis, it will pass through the focus after reflection. That's the rule number one. What is rule number two? Rule number two is if a ray of light passes through the focus, it will become parallel. Rule number two. Okay. And what is rule number three? Rule number three is if a ray of light passes through the center, if a ray of light passes through the center, it will retract its path. This is rule number three. Okay. This rule number three rules are used for either concave or convex also you can use. Suppose it is a convex. Suppose this is a convex mirror. The convex mirror, same three rules can be also applied. Okay. So suppose if I consider that this is the principal axis passing through the pole, I can apply these three rules. What is the first rule? If I consider a ray passing through the means parallel to the principal axis, rule number one, of course it will be diverging here, but it will look like that it is coming from the focus, because it is like a virtual point focus inside. Here it was actually passing through focus. Here it will look like it is coming from the focus. Okay. Rule number two. Rule number two means if it's passing through, but focus is not here, so it cannot pass. But it may look like a ray is going to pass through the focus. It will look like this. So this ray, this ray will become parallel to principal axis after reflection. This is rule number two. Okay. And what is rule number three? Rule number three is for a ray which is trying to pass through this. Okay. Rule number three you take now. So rule number three means suppose this is center of curvature which is lying inside. So if you take a ray which looks like it is going towards this center, looks like it will return back along its path. This is what is rule number three. So the same rule three, three rules are applied for convex also. The same three rules are applied for concave. These rules are used for making the images, right? So now let us try to find out first. It's very clear cut idea should be there. Otherwise, always there will be confusion in sign convention, because this chapter is a chapter where the main confusion happens in sign convention. Okay, which sign to use, what to use. Sometimes it is virtual, sometimes it is real. All those confusions should be clear, right? So let us right now first choose distance x and y, and I want to find out where will be the image form. So we will use some rays from there to find the image. Okay. So what rays we can take? So first you take a ray which is parallel to principal axis. Let us take a ray which is going like this. This ray will pass through the focus. Okay. So this point is the focus. We have taken this ray. Then what? Then let us take a ray which is passing through the another ray. Let us take which is trying to pass through the center of curvature. Take this ray which is passing through the center of maybe this lens I have not drawn properly. Let me draw this properly. So it has passed, let us say like this. This it is passing like this way, let us say. Okay. This point is focus F. Okay. This point is X here. X I have to show here also. This X. Okay. So this point is focus. X is this distance. X I can show that X is this distance. Okay. Then another ray, let us take another ray if I take, I have to pass through center. So let us consider center here. Let us pass through this center, almost this point. Then mirror also extend a little bit. So I will extend that this is the mirror. So this ray when it is hitting, it will retract backward. Okay, it will retract backward. This is point is center. Okay, so I want to prove this. No, something I want to prove. What we want to prove? We want to prove the relation between x and y. So note that these two reflected rays have meet here. This point is representing image. Okay, this point is representing image. So this distance from here to here, if I drop a perpendicular here, this distance will represent x dash, and this vertical distance will represent y dash. Y dash is the vertical distance of the image below the below the principal axis, and x dash is the horizontal distance of the image uh, from the pole. Right, pole is the coordinate system origin of that. So we want relation between x dash and y dash. This is y dash, and x and y. All these relation we want. Okay. So first of all, note that what will be the magnification? Magnification will be which magnification? Lateral magnification. Lateral magnification. I am going to write this as m lateral. That lateral magnification will be this distance y dash by this distance y. Okay, remember here these are distances. These y dash and y are distances. That means how much is the distance here and here. Suppose this is object, y represent object, and y dash represent the length of the image, the vertical direction. Okay, that's what it is. If now see, if I want to put as a sign convention, now suppose I want to put as a sign convention, then this is representing the height of the image, this is representing height of object. So height of object is positive above and height of image is negative. So if I write sign convention, I have to write y dash with minus, and I have to write y with plus. That is the idea. There cannot be any confusion here. Okay, y dash I will write. Suppose y dash is 10 centimeter and this is 5 centimeter. So this y dash I will write as minus with proper sign convention, isn't it? I will write y dash as negative and I will write y as positive. There is no confusion here. It's the same idea is there. Okay. Now let us do that. Now let us calculate, try to find out some method of doing this. Note that if I use this angle, suppose if I take this angle, some angle you take, let us say that I am taking this as alpha, this angle writing as alpha, and this angle I am writing as beta, this angle I am writing as beta. So what is tan alpha in this? Try to note that this one and this arc length are almost same, so no need to get confused with this arc length. You can assume that this, because this point is very close to this, so this length is almost same as the arc length. So now I am going to write tan alpha. Tan alpha I am going to write. Also note that this point is the focal length, so this distance is f here. This is focal length. Okay, this is focal length. So let us try to first write in this triangle tan alpha. So tan alpha I will write. Tan alpha in this triangle will be this height. Remember this height is same as y, so this is y only. Y divided by this length. This length is nothing but focal length. Correct? Isn't it? This is equal to focal length. Right? Then what is tan alpha in this triangle? This triangle is a small triangle here formed. This triangle I am showing here. This triangle. Tan alpha this. Here in this distance is what? Remember this distance is x dash. So this length is x dash minus f. This distance is x dash minus f. And this is y dash. So the same tan alpha in this triangle can be written as y dash divided by x dash minus f, right? Similarly, tan beta we will write. Tan beta also let us write. Tan beta in this triangle let us write. So remember this is radius because center is at a distance of radius. So this is equal to r. First of all, note that. And this is x. So this distance become x minus r. So tan beta, if I write in this triangle, this is y by x minus r. And in this small triangle, suppose if I am taking this small triangle here, this small triangle. So this distance will be how much? Because this is r and this is x dash. So this will become r minus x dash. R minus x dash. So and this is y dash. So this will be y dash divided by r minus x dash. That's what it is. No, from these two expression everything can be solved. You don't have to use similar triangles now. The similar triangle story is red tan. Red tan they prove by that method. Now we are using little bit trigonometries. Okay. So now let us use this. So from this we are getting this equation and this equation. So y by y dash we will calculate from this equation. So y by y dash if you calculate from first equation, it will become f by x dash minus f, right? And from second equation you calculate again y by y dash. Y by y dash will give again x minus r by r minus x dash. Now both are is equal to y by y dash. So let us equate them. Let us equate them and solve. So if you equate them, you will get f by x dash minus f and you will get x minus r by r minus x dash. Let us open this, cross multiply, open it. So f into r minus f x dash is equal to, this you have to multiply, x dash minus f into x minus r x dash minus plus r into f. So fr terms will get cancelled here. So what do we get from here now? Also now note that radius is 2 times of focus. So let us substitute that also. So minus f into x dash is equal to x dash minus f into x minus radius is 2 times of f. So 2f into x dash. Okay. So from here what do you get? You bring one side this term. So this side if you bring minus fx dash, minus will become plus. So it will become fx dash is equal to x dash minus fx. Now let us divide all these terms by a term. Let us divide all these terms with fx x dash. All these terms you divide by the same fx x dash. Divide this with fx x dash. Divide all terms we can divide. So if you divide it like this, then f will get cancelled, x will get cancelled. Here x dash get cancelled. Here fx get cancelled. So finally, what are we getting here is we are getting 1 by x is equal to 1 by f minus 1 by x dash. Now we can conclude that 1 by x plus 1 by x dash is equal to 1 by f. Remember here x dash f all are distances. They are all distances. Now if you want to choose sign convention, we can choose, right? Suppose they have given object distance x. You know left side is negative, so we put negative. Okay. Image is also from left side, then image it will come automatically. Generally we don't know, automatic calculation will come. Focal length we know for concave left side means negative, right side convex means focal length will be positive. According to convention, whatever we know we will substitute in this formula, so we'll get that, right? That's what it is. So suppose if I consider with a proper sign convention, so for concave focal length I will write as minus f, and object distance x I will write as minus u, right? And image distance x dash also left side minus v. So we can substitute u v f means it will become same 1 by u plus 1 by v, 1 by u plus 1 by v is 1 by f, right? It will become the same equation, right? But don't think that these two are different, they are the same equations. Okay? We got this. Now let us go to the magnification formula. What is magnification? Lateral magnification formula. Lateral magnification formula, if you use, here we know that magnification is y dash by y, but let me substitute properly, or without that let me first calculate. Let me calculate y dash by y ratio first. We have got it now, y dash by y. This is y by y dash we have got. So y by y dash we have got. So y dash by y reciprocal x dash minus f by f. So it will become x dash minus x by f. Sorry, x dash minus f by f. Okay, that is what we have got. Okay, so this we have already got now, but suppose if I want to put with proper sign convention, if I put, then note that if I put lateral magnification, y dash is what? Y dash is, what is y dash? That is height of image, which is negative basically. And what is y? Y is what? Y is height of object, right? That's what we will get. We can substitute with proper magnification. Either we can substitute it here or here. Suppose if I substitute y dash as minus height of image and y as height of object, that's what we will get, magnification minus hi by ho. Okay, this hi ho is with proper sign convention, right? Okay, now if I substitute x dash, what is x dash? X dash is image, that is minus v, you can say. Okay, minus v, f is what? F is focal length, which is minus of minus plus f, it will become, and this will become minus f, right? So what do we get from here? So now this you can write as v by f, or see, let us substitute v here, then maybe we can simplify this term. Magnification I want in terms of v by u, so v by f minus minus plus minus 1 comes, right? So what is v by f? So 1 by v plus 1 by u is 1 by f, right? So suppose I want v by f, how to calculate? Or f I want to eliminate. So 1 by f will be what? 1 by v plus 1 by u. So v I will write, 1 by f I will write as 1 by v plus 1 by u minus 1. So here this get cancelled, 1 plus v by u comes minus 1. Minus 1 cancel, it is coming v by u. But it should give us minus v by u. Where is the mistake has happened? It should give us with minus v by u. Okay, so I think this lateral magnification, they define as height of image by height of object. If they define it with this, that minus term will go multiply that side, so that's why minus v by u will come. Okay, so I think here we are taking just magnitude, so let us just take this as magnitude only, height of image by, but here we need to put this minus height of image by by height of object. So now y dash by y we are getting, but lateral magnification will be defined like this. Okay, so let us not define it right now. Let us keep it like this. Okay, so y dash by y we have got it. So minus h dash by h naught we have got it. Here we substituted. So this is nothing but minus hi by ho. But hi by ho is defined as lateral magnification, so it will come as minus v by u. Clear? That's how it is we are defining. So sign convention is very important to note How are we using sign convention? So the formula for lateral magnification is height of image by height of object, which is minus v by u. Here, of course, they are using with proper sign convention. Clear? Okay, so we got it. That's all. So magnification formula we did. And now note here that this magnification formula can also be written in terms of like this. So lateral magnification which we have written, which is minus v by u, and we know that 1 by, let us replace v. So 1 by v plus 1 by u is 1 by f. So from here 1 by v is 1 by f minus 1 by u. So 1 by v becomes fu by u minus f. So from here v can be written as fu by u minus f. If I substitute this here, so minus fu by u minus f divided by you will get cancelled. It will become minus f by u minus f. That is why this can also be written as f by f minus u. Lateral magnification can be written like this. Okay. But suppose I want to write in terms of v and f, then I will substitute u here. So you have to calculate them, right? So 1 by u will become 1 by f minus 1 by v. Then 1 by u will become v minus f by f, right? So from here u will come as f, I think fv by v minus f. Now let us substitute this in lateral magnification. So lateral magnification is minus v by u. Now let us substitute. So fv by v minus f. So v will get cancelled, minus times. So f minus v by f. This formula we can use for lateral magnification. So all these formulas are lateral magnification depending on what you are using. F by f minus u, or f minus v by f, or minus v by u. All these formulas are for lateral magnification, right? These are all lateral magnification. Done? Clear? Understood? Done. Okay, then what next? Next is, so mirror formula is over, magnification. Then there is a longitudinal magnification that also we need to understand. Longitudinal magnification. Longitudinal magnification. Longitudinal magnification means, suppose this is a concave mirror or convex mirror. This is the principal axis. So we are keeping the object like this way. This is the object. And let us consider this point is A, this point is B, object is kept like this way. Now note that when the image formation will happen, this type of image formation will happen, A dash B dash. Okay. So when image will be formed, it will be like this way. And object is like this way. Okay. So you can calculate here. So this is the distance of A, which is UA, and this is the distance of B, which is UB. And based on UA, you can calculate this is VA, and then VB you can calculate. Okay. So what is the length of object and length of image? So here again this lateral magnification, sorry, longitudinal, not lateral. Longitudinal magnification will be defined as length of image by length of object. So this is the length of image here, and this is the length of object here. So if I want to calculate this length of image, I can subtract VA minus VB, right? VA minus VB I can subtract. This length I am calculating. Okay, these are all length, magnitude only. And I want to calculate this, I will substitute UB minus UA. UB minus UA. Now I will take a minus common here. Then it will become like VB minus VA, and it will become UB minus UA. So this will become like delta V by delta U. That is the idea. So this formula longitudinal magnification becomes minus of delta u by delta v, minus delta u by delta u, sorry, delta v by delta u, minus delta v by, let me write here, so magnification longitudinal becomes minus delta v by delta u. And if you consider this object to be very small, for very small object, for very small object, we can write this longitudinal magnification as minus dv by du. Very small, right? Minus dv by du. Let us use this formula now. Okay, let us use this. So, if I write 1 by v plus 1 by u is 1 by f, and if I differentiate, so 1 by v differentiation is minus 1 by v square dv. Differentiation of 1 by u is minus 1 by u square du. Focal length is constant, so that differentiation becomes 0. So from here dv by du, dv by du comes as minus v square by u square. Okay, so dv by du comes as minus v by u. V by u is lateral magnification, so this is lateral magnification square, right? Lateral magnification. So this longitudinal magnification can be written as minus of minus, so it will become plus m lateral magnification square. That's what it is. So this is only for small object, small object, small sized object. Okay, this formula we can use. Magnification will be like this. Clear? Right? So like this we can do the calculation for lateral magnification, longitudinal magnification. Now take some examples about how magnification will happen. So suppose if this is a concave mirror, this is the principal axis, this is the pole, and if I take example, some object is there. Now suppose one rectangle is kept like this. So if you see this length let us say is A, and this length is B. Okay, so the area of the object is A into B, but the image will be formed, this side A is parallel to axis, B is perpendicular, so that rectangle which will become this A into, it will become A into longitudinal magnification, and this will be B into lateral magnification. So the size of the image will be A into longitudinal magnification, this is the new side, into B into lateral magnification. So if you calculate this, longitudinal magnification is m square times lateral into B into m lateral. So that becomes m cube lateral into AB. AB is what? AB is the area of the object. So m cube times lateral into area of the object. Okay. So this is called surface magnification. So surface magnification is equal to area of image by area of object. You can see here it is becoming cube of lateral magnification, like this. Okay. Similarly, we can have volume magnification also. Suppose that in front of a concave mirror there is a cube or cuboid kept like this way. Okay, if cube or cuboid is kept here, what we need to note is, suppose this side is A, this side is B, and this side is C, and let us say that the face is perpendicular like this. The principal axis is perpendicular to this face. Principal axis is perpendicular to the face of BC, right? So in that case, you should note that this A, which is parallel to principal axis, so A will become m lateral times a. Okay. What about B and C? B and C are perpendicular, so there will be only sorry, m is parallel now, so it will become longitudinal times. Okay, longitudinal times. So new cube image of this which will be formed. This image, the sides will get magnified. This will become m longitudinal into A, and B will become m lateral into B. C will also become m lateral into C. Now let us write the volume of the image. So note here that volume of object volume is A into B into C, length, width, height. Here volume of image volume will come m longitudinal into A, right? This is the length, and m lateral into B, again m lateral into C. So this magnification which you will get here is this image volume. You will get m longitudinal is m square lateral, m square lateral, m lateral, m lateral. It will become m power 4 lateral into ABC is the volume of the object, right? So here volume magnification, if you want to calculate volume magnification, so volume magnification is equal to volume of image by volume of object. Volume. So here volume of image is m4 times, so this is m4 lateral. Okay, so that's what it is, volume magnification. Right? Clear? We have understood this. So these are all the type of magnification type of questions that can come. Magnification questions that are coming will be based on this. What about the motion of objects? So note here that if they ask questions on motion of object in front of a concave mirror or convex mirror. So here this is a object which is moving. So object may be moving along this way and along this way both. So let us consider that object may move in some random direction V object. You can resolve its component Vox and Voy, right? Note here that this is the principal axis, right? This is the pole, and Vox, all these velocities are relative, so that means mirror is rest right now. Mirror is rest, or you can say that these velocities are relative velocities. Okay, so we can resolve velocities. So what about the image? How will the image move like that? How will image move? So image may also move with some velocities. We don't know. Some velocity it may have image velocity. Image will also have a component velocity. Velocity of image along x-axis, velocity of image along y-axis. Note that x-axis motion means how this x distance is changing, and y-axis means how y is changing. Okay, so let us consider this velocity of image along x-axis. Velocity of image along x-axis means it is like longitudinal, parallel to x-axis, correct? Parallel to x-axis. How do you calculate that? So see, let us write this as better to write as x-axis, right? That is the best way. This distance is x, object distance. This distance is x dash. So the rate at which x is changing, that is velocity object x. This is velocity of image along x. Okay. So what is Vox? Vox is dx by dt, and what is Vix? Vix is dx dash by dt. Correct. That is what it is. Suppose if I take the ratio of this and this, so Vix divided by Vox. If I take, this will become dx dash by dx. This is same as dv by du. Because dx dash, x dash is v, image distance, x is u. So dv by du just now we have calculated. This is minus m square lateral, right? M square lateral. This is, so from here you get velocity of image along x-axis is minus m square lateral into velocity of object along x-axis. So that's the formula. How do we calculate this velocity along this? Okay, that's what it is. That's what this is like longitudinal. You can remember like this way because this is along x-axis is longitudinal. Directly you can write it like this. Okay, you can write it like this. So Vix along this is longitudinal is what minus of. So this become m longitudinal into velocity of long x. Okay, this is how you can remember. What about along the perpendicular direction? So along perpendicular direction, remember y dash by y is, so that is m into that is m lateral only, m lateral into y. So that's why, and of course minus can come. You can write with proper sign. Minus will come, right? Minus will come. You can differentiate it. So dy dash by dt is equal to minus m times lateral with dy by dt. Proper sign convention I am using. Otherwise, just you can use because one is above, one is below, right? Isn't it? If you want, you can write plus here, but then you put with minus sign. Okay? Minus sign in terms of height. You can put this is height of image is minus m lateral into height of object. So dh height with dt will become minus m lateral into the height of object with time differentiation. So this is what it is. This is velocity of image along y-axis with minus m lateral into velocity of object along y-axis. So this equation will give us this result. So this is how we can calculate the velocities of the image with respect to, remember this is related to relative to the mirror. Mirror is not moving. If mirror is moving, then all these velocities are relative velocities with respect to mirror. Clear? So all these velocities are relative velocities with respect to mirror. So this is the formula for the magnification, means velocity of object, velocity of image. All these calculations can be done. Clear? So with this we can wind up this spherical mirrors. If you want, we can solve questions in one class, and already I have created 6 test papers on this. 6 papers I have created. I don't know whether you have written it or not. Please write it. It will give the clear cut idea about uh, what type of questions are coming. Level means tough levels are there in question test paper 5 and 6. But 1, 2, 3, or 4 papers are easy to moderate level. You can try that. Unless you try, you will not know what type of questions are coming. Okay. So then we'll next class we can see more problems on this. After finishing spherical mirrors, then we can go for um, this refraction. Then we'll move to refraction. Next class we'll start refraction. Okay. Fine. Yes, Nishan, Sam. Okay. So let us see in the next class then. Yeah. Okay. Till the time, work out problems, ask doubts in the class. Okay, keep questions. We want to discuss doubts. You keep any doubts you have. Okay, okay then. Bye. Good night.